and we'll fix our audio. There we go. That's a little better. All right, welcome back, folks. Last week we started working on the AWS Fault Injector Simulator solution, and we ran into a few little gotchas, primarily setting up the infrastructure for actually running the fault test took way longer than I would have anticipated. So I've got all of that. We finished all that up last week and we started working on the fault injector. We ran into a few little problems. So I'm hoping today we can finish up the actual process of getting the fault injector running and doing some actual tests. We simulated a test last week, but we didn't do it through the fault injector service. What we did was instead we ran it behind the scenes. What we're doing is we're running to do our CPU tests. The fault injection simulator, there we go, is using SSM automation documents to do that work. So last week we tested it by running one of the SSM documents directly. So what I'd like to do this week is actually get the thing working, the test working through the service itself, the injection service itself, rather than, kind of end running it and just running the document directly. So here's where we are. Let me go over to CloudFormation. Let's just add this to the top here. And you can see that this is all the work that we did last week with a few minor changes. I cheated a little bit here. One of the things I noticed last week when we were trying to do the test of the CPU stress test, we didn't have permissions we didn't give enough permissions to the injector service to actually write log data to CloudWatch logs, which is important to have that data so we can understand what's happening. So I did make some changes to IAM. We'll go through those. Our VPC is here, our security group, our load balancers are all set up. So what we need to do now is I'll walk you through the IAM setup. We'll redeploy our EC2 instance, which has our simple website on it. We'll just test to make sure that all looks good, and then we'll move on to the simulator directly, okay? So here we go. PyCharm. I'll show you first what I changed. In IAM, let's close these down. Right. Last week in IAM, all we did was we created a role and we associated to that role an Amazon managed policy document called AWS Fault Injection Simulator EC2 Access. It's a mouthful. And what that allowed us to do is that gave the fault injection service access to EC2, which it needed to run the SSM documents, right? But what we didn't give it was we didn't give it any other access. And we needed some additional access, like I said, for CloudWatch. So here's what I did. I just ran a bunch of tests manually and let them generate errors, right? Without really worrying too much about the fact that I knew it wasn't going to work. And all I did was I looked at the CloudTrail output, found the access denied messages, and worked backwards on this. So what we then did is we've got the IAM permissions or actions that we need to get this to work. Right? Oh, the other thing I did was I actually created a log group, which I'll show you. Okay? I made this a little open. It's basically being able to create log streams and put log events on any log group in the region and the account where we deploy this IAM CloudFormation template. Maybe today what we'll do is we'll tighten this up a little bit. Okay? And then you can see here some additional permissions that it needed. So that's what I did here. The other thing that I did was I created a log group. Here's our log group. I put that's our log group name, and we set the retention in days to a parameter of just 3, right? So we don't need it very long. I didn't get fancy with KMS here. I just left it and I said, hey, we'll use the built-in KMS, so the logs are encrypted just using the AWS KMS key. Okay. So let's deploy these again and get all of this working. if we go back to, what do I need to do? I need to go to our fault injection project. That's this one here. And we'll just run the pipeline again. And this will redeploy the stacks. Okay, so that'll get everything going. What we're missing right now is the updated IAM. I think we need to run IAM again. Can't remember if I backed that out to what we were running last week. We create the logs, and then EC2 gets deployed. And then we can figure out our final errors on the injection simulator itself. Okay, so if we go back to PyCharm, or no, Firefox, where are we here? There we go. Actually, I'm already where I want to be. I want to go here. So here's the log group. Super simple, right? So we'll get that created. That's an easy one. There's our log group. Great. And you can see here, retention of 3 days, no metric filters. Like I said, we're not using a custom KMS key or anything like that, so that's fine. One of the things that I'd like to try is log groups now support this data encryption or data protection, so you're able to redact fields based on the permissions that a user has. So that might be kind of interesting to see how that works too. For a future stream maybe. So that's good. Go back over here. Here's our EC2. This is going to set up our launch template, the actual auto-scaling configs, an EC2 instance. That's weird. I don't know if we need that or not. And then our scaling policy. Because ultimately what we're trying to do here is test the scaling policy, making sure that we actually see it add instances as we scale, as we basically run a CPU stress test on one of the targets, which should then cause the scaling policy to kick in and add additional nodes, right? Now this is interesting here. I don't remember what this is. Maybe before deploying this, let's go back over to PyCharm and have a look at that EC2 template before we go any farther. So there's our launch template. There's our auto-scaling CPU. Oh, yeah, this is, yeah, of course. Ugh. This is the EC2 instance that we launch. Do we actually need this? See, this is launching an individual EC2 instance. Isn't it amazing how quickly you forget what it is that you've done? You know, I'm going to leave that for now, and we'll work backwards off of this. We'll see what this deploys, because see, my brain is saying this is launching a single EC2 instance based off the launch template and a default version, which is fine, but really what we're after is this up here, the, where is it? Here, right? Our launch template is used by the auto-scaling group, and we're going to build everything out with auto-scaling. Yeah, I can't remember what that was for. Oh, the other thing is, and I don't remember if we did this last week, the way the fault injection service works is you basically, you give it targets, and there's a bunch of different ways to basically assign a target to your test, your experiment, they call it. So what we're doing is we're just setting an arbitrary tag. The key is stress test, the value is going to be true. And what we're doing is, the idea is that when the experiment runs, it will randomly select one, basically 50% of our web servers will be targeted. In this case, it'll be one machine that gets targeted, and it's going to use this tag value to determine what it's going to run against, where it's going to start the CPU stress test. So that's all that is. So yeah, let's run this. We'll go back over to Firefox. And actually, let me close this down. There we go. Let's go to Firefox. And let's run this. And like I said, we'll just check that. Check that one EC2 instance. I don't think we need that. There's our launch template. Here's our auto scaling, and this is the web server that's coming to life. Okay, so if we go outputs, resources, see it launched an EC2 instance. Right there. Let's do this. Ooh, it's starting 2 now. Okay, so that's coming. This is being launched. I'm looking for auto scaling here. See, there's no auto scaling info here. If we go to this one, launch template, again, no. Usually it'll assign an, oh, there it is, auto scaling group. Okay, so we know that this machine is coming from the auto scaling group. Does this one have that same tag? Launch template. It doesn't. Oh, there it is. Yeah, so that's also coming from the auto scaling. Okay, well, let's let it finish. Okay, it's done. So we've got our scaling policy, our launch template. This is the one that I'm not quite sure what it's doing. Let's go here. Yeah, okay. So here's what I think is happening. In our auto-scaling group, we've asked it to launch 2 instances. Okay. This is, I'm running a training class at the same time, so we'll just ignore that. Okay. So if we go in here, desired capacity, minimum capacity, maximum capacity, and if we go to instance management, these are the 2 machines. So it ends in 24 and 60. Those are the 2 machines that are being launched by the auto-scaling group itself. If we go back to here, so what is it, 24 and 60? So 24 and 60. This one is that web server EC2 template, which we don't really need. Sorry about that. So what I'm going to do with this one is we're going to delete this. We're going to say actions or instance state, terminate. Just tell that one to go away. And we'll flip back over to PyCharm. And we don't need this. Okay, so let's just push that back. That guy up. All right, perfect. So that'll clean that up. And what should happen is if we go to load balancers, here's our load balancer. If we go to target groups first, we go here, and both of our web servers are passing the health checks, and we can go here, and there we go. Okay, so that's our super fancy website. Perfect. So that's all good. Now, did it deploy a change set here? Yeah, so this should just remove the web server, which I did manually, so I don't know what's going to happen here, actually. I think it'll be okay. Well, we'll let that run and see what it does. That leaves us with this, our actual fault injection simulator. Let's deploy what we have in here. So this is actually going to create our experiment template. So we'll execute that. Let's see if that works. And this is finished now. So we've got that cleaned up. Oh. Stress test message, action ID, expected a JSON object, required key to action ID is not found. Targets, instances not permit. Wow, there's a lot of errors. So let's see if we can sort these out. Okay, we'll go back over here. Let me just read that again. Validation failed for resource FIS CPU stress with a message action ID expected type JSON object found as string. Okay. So if we grab this, let's just check out what's required. It's probably a spacing issue or something like that. Actually, you know, when we did this last week, I found looking at this helped us out. Oh, see, this is what I did last. Yeah, this I remember this from last week. See this? This is like an action name almost, or something like that. And I don't have that in my template. I remember this messed us up last week. See this? I've got actions with an action ID. So what I really need to do is something like this: stress test, and then all of this goes like that. I think that's what the problem is. Let's just check that against this. Parameters, see how under here we've got actions, parameters, targets. Okay, that's good. Let's make this one change, just fix this spacing and see if that fixes our problem. Ah, getting ahead of myself. Yeah, it helps if we clean up the failed stack first. So I need to clean this one up. So we'll delete this. And then we can actually deploy the stack. Okay, there we go. And then all we'll do is we'll go back here. Try it again. All right, it's not quite as messy as it was before, right? So we still have a validation message, targets web server required key selection mode. Okay. So that is under targets. This here, I think this is a spelling mistake. Yeah, this should be under targets. Here, I'll show you. So here's our, this is sort of how we tell the experiment template what to target. and I put selection in our template versus selection mode. That's this here. So we'll say selection mode. Oh, I almost did the same thing again, didn't I? Alright, well, we'll just give it a second. Oh, there we go. Okay. So let me push this update. All right, there we go. Okay, perfect. Now, if we look at, this is our new experiment template ID. If we go over to here, we go to experiment templates. Here it is. We should name this with something, right? So let's add the missing name first. This is just a tag value. Let's fix that up. If we go back over here, right, it just has tag values. Okay. So let's see. Do they give you an example of this? See, the tag values here are set up a little differently than some of the other services. So, okay, that's pretty basic though. So let's go over here and we'll say tags, and it's just going to be name, and we're going to do this. I don't know if this will look right or not, but we're going to say sub AWS stack name. What did we call the stack itself? FIS development FIS. Not a great stack name. Maybe what we'll do instead is we'll just keep it simple. Instead of using sub, we'll just call it CPU stress test. Why does it not like that? Tags is duplicated. Targets, tags. Oh, that's interesting. See this? Targets. Oh, I see what I've done. Okay, so, yeah. I left this space in here for some reason. I thought it was two definitions, but it's all one. So what we could do is just go name, CPU, stress test. Okay. There's this. And it, oh, look at that. The name change requires a replacement of the experiment. Okay. Alright, so it's going to create a new experiment and then delete the original one. And if we go back over here now, there we go. That's a little better, right? Alright, so at this point, we've got, I think everything's set. Go over here, we go to EC2, we've got a couple servers running, and remember I was mentioning about the tags? So we've got, where is it? Oh, right at the top, stress test is true. Okay, and that's what the value, that's the key value that we're looking for, or sorry, the tag key value pair that we're looking for as part of the experiment. So we can go over here and we can say start experiment. Okay. We can add tags to the experiment itself. We won't worry about that. We'll start it. Yeah, we just have to acknowledge that we understand what we're doing. Say start. Failed. A required parameter for the document is missing, or an undefined parameter was provided. Okay. Well, we're getting close now. It's a little better. The one thing that I was experimenting and trying some stuff out, the one thing that I did like was this. So this is kind of neat. Obviously there's a delay, but if you go now, this will set up CloudTrail and give you this search. This is your experiment over here. This is your experiment ID, and then we can go over here and we can just use that as a username. So you can just click that link right from in the experiment itself, and it sets the filter up in CloudTrail. We'll leave this for a minute and we'll have a look at what it's telling us. So in the meantime, a required parameter for the document is missing. So that's right here. These are the parameters that we're passing into the document. All right, so this is the document that we're running. This is the pre-built stress test for the fault injection simulator. So let's work off of this. Let's do, if we go back over here and we go to actions, and we can look at the template action, and under, I think it's parameters. Yeah, I thought last week, oh, here we go. See this? For more information, see actions in the user guide. So we can go over here. This will show us all the various actions that are available, and we're using an SSM document to do the stress test. So here we go, pre-configured SSM docs. And we're using this one. Okay, so we're using the stress NG tool, blah, 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 blah. Document parameters. Duration in seconds is required. So the duration of the CPU stress test in seconds. CPU is optional, optional, optional. Alright, so I think this is what we're missing right here. Is this JSON string. Okay, so if we look at this, so it's simply just parameters is a map of string. Alright, so yeah, they're pretty much all the same, right? The question is, how do I push this in? Maybe there's an example in here we could look at. Parameters. And then this is too simple from what we're doing. There's our ARN. Let's look at, we'll come back to the duration in a second because we're providing two durations now. We're providing duration in the SSM document, and then there's this duration. Okay. How do we apply? Go over here. How do we apply the parameters to this? Again, this is pretty much the same. I must be missing something here. You know what we could do just to figure out this syntax? Let's do it like this. Let's go to FIS, we're going to go to experiment templates, and we're going to create a new one. And we'll just call it demo template. Okay. And we're going to just mimic what we did in the other one. So demo action. We've got an SSM doc, and we want, it's this, send command. The ARN of the document, we can steal that from here, from our template, and then just modify this, because we're running in CA Central 1. Now, this is where the parameters come in. So for now, why don't we just take the example that they gave us, and where did that go? We're just going to dump it in like that. And then what we'll do is we'll run a CLI command, and this will just give us, I'm just not sure about the format for that, and I don't see an example. And then see this? Okay, so this is the duration of the test, and this is the length of time to monitor the SSM command itself. Okay, so we'll make it 10 minutes, right? Duration is, we don't care about this, 60 seconds, and we'll monitor for 10 minutes. We're not actually going to run this. And then from here, oh, we need to save this. Okay, there's our action. And then in here, we can edit our target selection and say selection mode. This is exactly what we did in our template, 50%. And then up here, we're going to say stress test is true. So we'll save that. We've got the role set up. And we can go to our log group. We'll just browse for the ARN. We want to use this one. Version 2, so create it. Okay, we'll just say create. Invalid. Oh, what did I do wrong there? Document ARN. Okay. Sure looks right. Invalid value. Oh, look, I chopped out one of the stanzas we need. So we've got the region and then the account ID. We don't need the account ID for this, the document ARN. So that's just a, let's try, oh, we got to save it again. I always forget. Up here, you got to say save. And then we can say create. Okay, there we go. So now all I need here is I want to take this and we'll just do this in Cloud Shell because it's easy. We'll say AWS FIS. Is it get experiment template? And then let's do help. Let's see if that's correct. Okay, so that's right. And then we just need dash dash ID. Dash dash ID is this. Oh, you know what else I want to do? I want to do dash dash output YAML. And this will give us right here. Oh, okay, just document parameters. That makes sense. Okay, so if we go back over here then, document ARN, that's there. We're going to do document parameters, and we will grab this, but I'm going to change this. We want the duration of the test to go for 10 minutes, and we'll monitor the test for 10 minutes. And then I want to add in here one of the options. If we go back here, is not the number of CPUs, but the load percent. Because if we don't do it, it'll do 100% full load. And I think we'll just like set it for 70. So we can say load percent. Load percent is 70. So we'll do that. Where do we go? CloudFormation. There we go. Here's our update. It's not going to replace our current experiment. So why not? Okay, looks good. Let's go back to our experiment here. We'll delete this one because we don't need it. And let's just see. We can go here and we say actions, view details. Here's the action. And there's our document parameters. So duration of 600, load percent, and install the dependencies if you need it. Which I think it does that by default, but that's fine. Here's our targets. So we're looking for 50% of any EC2 instance that is stress test equals true. In our case, that'll be one instance because we only have the 2 running. Okay, that's fine. So that's that. What else do we have? Oh, look at that. We can export the stress test. So you get your CLI commands if you want. Here's our tags, and then this is our timeline. Okay, so let's start our experiment. Start. Running. All right. Last time it failed pretty quickly after it went from, what was that, pending to running? Okay, so that's good. That looks good. 2 things then I want to do. We'll open up. Oh, I was going to show you this too. So event history, there we go. So these are the commands, the EC2 commands that were run under that experiment. if we change this, let's get a resource type, resource name, and instead we'll just look for error code. There we go. Right? Invalid parameters. So if we look at this, document ARN, yeah, it does not support parameters. Seems weirdly worded, but yeah, we figured it out. So that's good. Well, let's close this one. Actually, let's just go like this. We're going to go to Systems Manager first, because really all this is doing is executing a document on our behalf. So we could go to Run command, and inspector, there it is there. And we can look at the details of this command. So there's the instance that it chose to use, right? Our 50%, grab 50% of the EC2 instances that are tagged in a certain way. So this is the instance that it's running on. Okay, so error message. I don't think that matters. Yeah, here's where it's installing the dependencies. So far, so good. We'll leave it maybe here. But then we could also go look at, what, 0.24. We'll leave that window open. So here's 0.24. Oh, I was like, look, it's scaled up, but it's at 0.4%. Might take it a little bit of time. Why don't we do this? So now we're seeing, it's definitely different, so maybe it's already working, because there's our other machine. It's at, what, 0.5%? This one's up around 6.5%. And let's do this. We'll update this every minute and see what it does. So now it's a waiting game. But what I'm expecting to see here is this CPU utilization continues to go up, which drives the overall aggregated CPU utilization for our entire autoscaling group. And then we should start to see other machines get launched, right? Because we're doing the stress test at 70%. And if I recall, our autoscaling policy, we've just got a link tracker on here. Is it called a link tracker? I think so. Dynamic scaling policy, target tracking, and we're saying keep it as close to 50% as possible. So we should be able to get over that and then have our instances scale. Maybe we'll go here too, because now we can see the activity happening. Okay, well, let's give it a little while and see what happens. Kind of like watching paint dry, but so it still says in progress. Doesn't look like anything's changed, right? This should actually have multiple steps, because if we go back and we look at, if we pull up the actual automation document it's running, so if we go back to Systems Manager, we go to Documents, and we search here by prefix equals AWS FIS. This is the one we're running. And if we look at the details, actually no, the content I think it is. So here under main steps, right? There's the first step. This is where we're installing our dependencies. Then it has, okay, so once it's done that, then it runs the stress ng commands. That's it, it's just two steps. Still nothing. Oh, there we go. It's definitely going up. Let's set this up to go every minute too. Not weird that it hasn't changed here. I would have expected to see the CPU utilization on that particular instance continue to go up. It's kind of leveling out. I guess at this point we just have to be patient. Let's see what happens. See, that's still step 1 there. So, see, this is the install dependencies. Yeah, it's funny, I would have expected to see, like, step 1 finish, it says success, and then we would go to step 2. Is there, like, a delay or something in here? You know what we could do, just for interest's sake? Let's go to EC2. We've got, I'm pretty sure when we set these up, we set up SSM. So here's our, oh, there it goes. It's still going up. Okay. Patience, I guess. Let's see if we can connect to this machine. Session manager. Alright, there's the stress test running. Maybe it doesn't update stage 2 until the test is done, and we ask the test to go for like 10 minutes. So this is chewing up a lot of the CPU now, so it's basically at 100% now. That's weird too, because didn't we put in there load percent at 70? Seems to be bouncing kind of all over the place. Okay. CPU seems to not be going past 35% for the EC2 instances. Anything on the auto-scaling side? No. Oh, look at, let's enable that. What's going to be in here? Terminating instances, total instances. Okay, well, I guess we'll let that run for a bit. It's interesting that it's not going past 35%. As we look here, we're running at 100. I think the aggregation too for the log data, or not the log data, the metric data, I think isn't going to be a minute. I think it'd be every 5 minutes by default, because we don't have, I don't think we enabled enhanced monitoring, I think it's called, to get that additional metric data. So that is also probably something we could look at. While we're waiting, why don't we do a couple modifications. So if we go over here and we go to EC2, so here's our launch template. You know, oh, monitoring true. Let's have a look at that. So let's go look at launch template first. And that's under launch template data. And then we have monitoring. The monitoring for the instance. Enabled true. Okay. Okay, so we have detailed monitoring, otherwise basic monitoring is enabled. Now, my recollection is if you enable detailed monitoring, you get more metric data with shorter time periods. I think it goes from 5 minutes to 1 minute, so maybe we do have that extra data. But again, why is this not going above that? Okay, well, the other thing we could look at is in our auto-scaling group, I had to enable those auto-scaling metrics. So if we go back here, let's have a look. Maybe we could just turn that on in here. I think it's metrics collection. Enables the monitoring of group metrics for the auto-scaling group. By default, these are disabled. Okay. Let's check this again. Oh, look at that. It's dropping off. What over here? Evening out at about 70%. Isn't that weird? Maybe by dropping the CPU load from 100 to 70, maybe the aggregate usage just isn't enough to get us that 50% threshold. So we're going to make a couple changes and then we'll run the experiment again. So let's do this. We're going to first off enable metrics collection. So if we go back over here, we'll put it here, metrics collection. And how is this structured? It's a list. All right, so granularity is required. Granularity. And that is a string. The only valid value for this is 1 minute. Okay, so 1 minute like that. And then what metrics do we... Oh, man. Oh, okay, look at this. Here we go. So in this section here, we set the granularity because that's required, and then metrics, and these are the metrics that you want to collect. If you specify granularity and don't specify any metrics, then all metrics are enabled. That's what we'll do. We'll just collect all metrics, at least for our test environment. Right? That's fine. And I think the other thing we're going to do is we're going to see our min capacity. We're going to change the minimum capacity on this from 2 machines to 4. And then we will maybe increase the number of machines that we're running our load test against to try to artificially push it up a little more and get the actual values that we need in order to trigger an event or a scaling event. Okay. Let's check again what's happening here. Well, it doesn't really seem to be tapering off, but I don't think we're throwing enough at it. Yeah, it must be over because see now our, what was that called? Stress NG is gone. I wonder, did that write to some logs or anything? out. I guess I could have run a tail, right? I just wanted to see if anything happened in here. Oh yeah, so here's our document info. Initializing. Oh, I got logged out. Ah. Well, we won't go back to that. Let's go back to FIS now. And we'll have a look at our experiment. And it completed. You know, I think before we get too fancy, let's make... Oh, sorry, I'm looking at the wrong screen. Sorry, I got logged out. This is what I was looking at. So there's our experiment. It completed successfully. And we didn't actually see the activity that we expected. And I think that's because we just didn't generate enough of a load on that web server to get the aggregate CPU utilization for the entire group above 50%. So what we're going to do now is we are going to make a change over here. So I modified our auto-scaling group and I just added that granular metrics collection. That's all I changed here. So let's actually just do this. Okay, so we'll do that. And then the other thing we'll do is in FIS, I'm going to remove the load percent. And we're going to hit this thing with 100%. Okay. And then maybe down here, why don't we do 100% here too? So what this should do then is select both of the EC2 instances and run the stress ng command against both of them. That should push our aggregate usage up enough, right, to get a scaling event to occur. So we'll just say, what did we do here? Removed CPU load and modified selection mode. Okay, so let's push those two changes. So there's EC2. That should get us our first change we need to do, because the EC2 stack has our auto-scaling in it. Right, so that's just going to modify our auto-scaling configs. Okay, let's just have a quick look. So we go over here. This is our auto-scaling configuration, and really all we changed here was monitoring. So now we've got auto-scaling group metrics collection enabled by default. And yeah, it looks like it's collecting some stuff already. Is that like within the last... Yeah, that must be from maybe the end of the other test, and now hopefully we'll see something change. And then if we go to FIS, this is just modifying by removing the CPU load. So we're going to use 100% load test now, and we're going to also hit all of the targets instead of just one to get that CPU utilization higher. If we go FIS, let's just have a look at it again. targets. We're saying 100% this time. And then where was that? It was under here. Yeah, so now we have duration and install dependencies only. And this way, I remember in the documentation, if you remove the CPU value, then it defaults to 100% load. Okay, so let's see what happens. All right, we're off to the races. So let's leave this window open, and then we're going to go back over here, and we'll do the same thing we did before. We'll select both of these. There's our CPU utilization. So this should start ramping back up again. And let's do a minute, and we'll do the same thing over here, 1 minute. What was the other thing that we brought up last time? Oh yeah, we looked at Systems Manager, and we brought up the run command. Where is that? Here we go. And here it is. So now we've got both our targets identified, both the EC2 instances. All right. Desired capacity pending. So these are auto-scaling metrics, and then here are our metrics on our EC2. So there's our little test window that we did the first time. What time did that start? Basically 1943, and went to, yeah, 10 minutes basically, right? So let's see what it does this time. Oh, we gotta re-enable that. You know, the other thing we could do, and I don't have this off the top of my head, but you know, within your auto-scaling group, you can mix and match on-demand and spot instances. It would be interesting to set that up and then watch as these machines are launched. You know, we set up the, you know, maybe 75% on-demand, 25%, 75% spot instances, 25% on-demand instances, and then as the new machines come on, we use those spot instances, cheap compute, to stand up the additional instances we need, and then they go away at the end. That might be kind of an interesting use case as well. All right, nothing yet. Nothing yet. Oh, there we go. So it's starting to ramp up here. We didn't see that same little uptick in the EC2 instances themselves, but maybe we will here shortly. Oh, there we go. All right. So, in theory, I would assume in a very short period of time here, we will see some new EC2 instances getting launched. Because now we're definitely above our 50% target for the CPU utilization on our auto-scaling group. Remember that target tracking value? It's funny that this hasn't changed. I don't know what the difference is between them. We should also take... Oh, you know what we could do? We could do this. Instance state is pending. Okay, so now we're going to look at running and pending machines. So when something comes to life, we should see it here. Isn't that funny? Oh, there we go. It's just, yeah, I'm not being patient enough. So activity, there we go. So now we're adding capacity because we're well above the 50%. Okay, so launching new instances. Patience is a virtue. There we go. Okay, so new machines coming to life. Still strange that this isn't updating. Okay, so that is what? Basically 1800. Wait a second, what time is it now? No, sorry, wow. It's 8 o'clock. 20, right? 1800. I'm going backwards in time. Yeah, see, this is giving us much more granular metrics here. Like, these are by the minute. And then over here, we're seeing this. Oh yeah, this is every minute still. Yeah, I don't know. 47, 40, yeah, I don't know. Well, we're definitely seeing new machines come to life, so that's good. So there's our 2 new machines. There we go. Finally see that uptick. If we do this, yeah, still loading, no problem there. Really need that one. So yeah, see, we could fine-tune some of this so that the warm-up period maybe is a little too long. In this case, the default warm-up period's what, 300 seconds, which is 5 minutes. Maybe we could tighten these up a little bit. Where's that auto-scaling one here? Okay, so there's all the machines running. We've got 4 machines now. Let's get rid of some of these. Type, let's leave that. I don't need any of this, right? I was looking for, let's turn that on, and then there is a life cycle. This one. There we go. So it's adding additional ones now because these guys are out of warm-up period, the original ones, these first 2. So now we're doubling it again because if we look here, yeah, our CPU utilization hasn't dropped at all. Now here's something interesting. I wonder if we go onto one of these new machines. These are the originals. So let's go on to one of these. Yeah. Okay, so it's not continuing to identify new targets. It's still just using those original 2 machines as the targets, right? For our, it's only running the stress NG on those 2 machines, but we're running those 2 machines at 100%, and then these new guys are coming up, and they're not, it's not continuously looking for new targets. We're definitely scaling now. Yeah, there's our capacity changing. Total capacity units. Okay. So it definitely works. What did we do here? So we said maximum of 20 machines. Okay, so now we've got, what are we up to? 8 machines running total? Okay, so they're all launched now. I would have thought that this would have started to drop, would it not? My understanding of this one was this is aggregated CPU performance across all of the members of the autoscaling group, and we've gone from 2 machines to now 8. And it's scaling again. 1, 2, 3, what is it, 4? It's adding 8 more machines. Yeah, let's have a look at this. So let's do AWS EC2 autoscaling. CloudWatch metrics. Or sorry, let's just do monitoring. View monitoring graphs. I wanted to see if it had... It's just notifications. If it had something about the aggregate CPU utilization. Is this here? Oh, there it goes. Now, does that mean that our test is over, though? So that's what? 05 to 15. So yeah, it basically pegged that at 100% for 10 minutes. And then this is going to drop, I would assume, and we would then have scale in. And this here is interesting on how it's just basically doubling the capacity each time. There's definitely more to kind of poke around here and see how this works. Let's go back here. There we go. So we go for a short period of time at 100%, and then it drops to basically back to 0 when the stress test finishes. And I guess what's going to happen now is these instances will start getting shut down as quickly as they came to life, because obviously we're not close to 50% anymore, so we'll start terminating machines. Obviously, this is not a problem there. And let's go see. I would assume that our experiment at this point is finished. Yep, there we go. Completed. Our 2 targets. There's our timeline. So this is when we're monitoring it. Oh, and here's the log event stuff. So not a ton of information, right? Start. This is where it's selecting the targets. This is where it's determined the targets. There we go. And then we're going to run our commands. So in this case, we action start and then what? 0, action end. Yeah, so there's our test completed. 15:15. Oh yeah, so 05:15 to 15:15, so there's the 10 minutes. And then we get the document, or the log saying we're finished. So it works. And the scale in is going to take a little bit of time. Maybe while we're waiting for the scale in, let's have a look at the auto scaling policy a bit more and just see if we can maybe figure out. I just didn't think I would see it doubling like that, and I'm not quite sure I understand why the CPU utilization didn't come down. The aggregated CPU utilization didn't come down. Maybe it's something to do with the warm-up period, because the warm-up period's 5 minutes, so maybe we're scaling, but we're not including that CPU utilization in the overall aggregated utilization metric for 5 minutes, which maybe makes sense. I don't know. Let's go back to EC2 and let's have a look at. Let's start with the auto scaling group again. If we go back over here and just see what other values we might be able to fine tune here. So cooldown we don't care about. Somewhere in here there's a default instance warm-up. The amount of time in seconds until a new instance is considered to have finished initializing and resource consumption to become stable after it enters the in-service state. During instance refresh, waits for the warm-up period after it replaces an instance before it moves on to replacing the next instance. EC2 autoscaling also waits for the warm-up period before aggregating the metrics for a new instance with existing instances in the CloudWatch metrics that you're used for scaling, resulting in more reliable data. Okay, for more information, see set the default instance warm-up. Let's go have a look at this. To manage various warm-up settings at the group level, we recommend that you set the default instance warm-up even if it's set to 0. To remove a value that you previously set, include the property but specify -1. However, we strongly recommend keeping the default instance warm-up enabled by specifying a value of 0 or some other nominal value. Sometimes those just doesn't make sense to me. Let's have a quick look. So how long your instances need to finish initializing and for resource consumption to stabilize after they reach the in-service state. Aim for an optimum balance between collecting usage data for legitimate traffic but minimizing data collection associated with temporary usage spikes on startup. Suppose you have an autoscaling group attached to a load balancer. When new instances finish launching, they're registered to the load balancer before they enter the in-service state. After the instances enter the in-service state, resource consumption can still experience temporary spikes and need to stabilize. For example, resource consumption for an application server that was downloading cache lards, blah, 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 blah. The instance warm-up provides the time value necessary for resource consumption to stabilize. Yeah, so see here, if you're not sure where to start with 300 seconds, which is the default, and then increase or decrease until you get the best scaling performance for your application. You might need to experiment. Alternatively, if you have scaling policies that have their own warm-up time, you could use this value to start for more information. Okay, so if we look at this, our default instance warm-up specified in seconds, and if we go over here and look at the details, health check is different. So if we're only waiting 120 seconds there, that's what, 2 minutes? And that's our default cooldown. Where's our warm-up. Yeah, I'm not sure. Instance types requirements. Oh, here we go. Default instance warm-up is disabled. So let's add that. And we'll just match it up to the 120 seconds here as a test. So that's 2 minutes instead. Okay, so if we go back over here, we can say default instance warm-up, and we'll say, we'll just do this. And we'll add that as a parameter up here. And we'll set a default value. We can always override that later on in the deployment script. So that's the first thing. Okay. Now the other thing I thought we could just try here, since we're poking around in auto-scaling, is we can, remember I mentioned the on-demand versus spot instances? So what we could do is we could look at how to set that up as well. Yeah, and that's this here, the mixed instance policy. This policy includes properties that not only define the distribution of on-demand instances and spot instances, the maximum price to pay for spot instances, which is optional, and how the autoscaling group allocates instance types to fulfill on-demand and spot, but also the properties that specify the instant configuration information, the launch template instant type. It can also include weighting for each instance type and different launch templates for individual instance types. So yeah, you can get really complex scaling instance policies here to mix and match the instance types and how you want to pay for things. Let's open this up in another tab. Okay. So this is how we can, so you can do two ways to do that, two ways to select your instances. Manual, where you specify the instance types and sizes that you want to use, and then you can use attribute-based selections instead. I think we'll try manual and then maybe add some weighting to it. Let's see if we can go through here. So first let's add this to our template, and we'll put that here. Mixed instance policy, and what is it? Is it a list or an object? I'm not sure. It is, where did that go? It's an object, okay. So here is what it looks like. Instances, distribution, and launch template. What is this? On-demand allocation strategy. Okay, so let's build this out piece by piece. Maybe I'll keep on the pie charm screen here. And the first thing we want here is, what was it? Instances distribution. Alright, and then we've got a bunch of things here. Our first option is on-demand allocation strategy. This is the allocation strategy to apply to your on-demand instances when they are launched. Possible instance types are determined by the launch template overrides that you specify. And if we do this on-demand allocation strategy, we have one of two lists, or one of two values we can add to it. Lowest price. So this uses price to determine which instances are the highest priority, launching the lowest priced instance types within the AZ first. This is the default value for autoscaling groups specify instance requirements. And then we have prioritized. You set the order of the instance types for the launch template overrides from highest to lowest value, from first to last in the list, and then auto-scaling launches your highest priority instance types first. If all your on-demand capacity cannot be fulfilled using your highest priority, there we go, instance type, then EC2 auto-scaling launches the remaining capacity from the second priority instance type, and so on. This is the default value again. Okay. And cannot be used for groups that do. Okay. I think we're okay. So what we're going to do is we're going to make this prioritized, and then we'll order what we want. Okay, so that's the first thing. Then we have another thing that says on-demand base capacity. This is the minimum amount of the auto-scaling group's capacity that must be fulfilled by on-demand instances. This portion is launched first as your group scales. This number has the default unit of measurement as the group's desired capacity. If you change the default unit of measurement, number of instances, by specifying weighted capacity values in your launch template override lists, or by changing the default capacity type setting of the group, you must specify this number using the same unit of measure. Bah! On-demand capacity. Okay, that's a weirdly worded in my brain. Let's come back to that one. On-demand percent above base capacity. This controls the percentage of on-demand instances and spot instances for your additional capacity beyond the on-demand base capacity, expressed as a number. For example, 20 specifies 20% on-demand, 80% spot instances. If you set it to 100, then only on-demand instances are used. Okay, so let's do this. Okay. And for now, I'm going to hard code these values. If this works, then we can always turn these into parameters. I'm going to use their example. So we're going to say anything above our on-demand base capacity, 20% of it will be on-demand, 80% of it will be spot. And then I'm going to go back to the on-demand capacity piece, and we'll hard code this for now too. The default is 0. Let me read this again. It says, this number has the same unit of measure as the group's desired capacity. If you change the default unit of measure, number of instances, by specifying weighted capacity values in your launch template, or by changing the default desired capacity type setting of the group, you must specify the number in the same unit of measure. So right now, we're using, I think it's just number of EC2 instances is how we're doing it. That's how we're measuring it, right? As number of instances. So this would be 2 then. Okay. Okay, so now the next thing is spot allocation strategy. This is the allocation strategy to apply to your spot instances when they are launched. Possible instance types are determined by the launch template overrides you specify. The following lists are valid values, and we've got a bunch of them. Capacity, here, let me show you what I'm reading here, because there's a lot of words here. We've got capacity optimized, that requests spot instances using pools that are optimally chosen based on your available spot capacity. This has the lowest risk of interruption. Then we have capacity optimized prioritized. You set the order of the instance types for the launch template overrides from highest to lowest, first to last in your list. Autoscaling honors the instance types on a best effort basis, but optimized for capacity first. Lowest price. Request spot instances using the lowest price pools within your AZ across the number of spot pools you specify in the pool's property. To ensure your desired capacity is met, you might receive spot instances from several pools. This is the default value, but it might lead to higher interruption rates. And then finally, price capacity optimized, which is the recommended. The price and capacity optimized allocation strategy looks at both price and capacity to select your spot instances that are least likely to be interrupted to have the lowest possible price. That seems to make a lot of sense. Okay, so we'll take this, and again, we're just going to hard code all this for the time being to see how it works, and we will put that here. Okay. All right, what's next? Spot instance pools. The number of spot instance pools across which to allocate your spot instances. The spot pools are determined from the different instance types in the overrides. Valid only when spot allocation strategy is lowest price. So we don't need that then, because we're not using spot allocation strategy of lowest price. We're using the recommended price capacity optimized. Okay. Spot max price. The maximum price per hour you are willing to pay for a spot instance. If your maximum price is lower than spot instance for the instance types you selected, your spot instances are not launched. We do not recommend specifying a maximum price because it can lead to increased interruptions, which we don't want. So I think we're done with this then. So we can keep it like that. Okay. Whoops. There we go. Now, the other thing it kept mentioning in there was the overrides piece, right? So like if I go back over here, how many times did we read down in here? Where was it now? Possible instance types are determined by the launch template overrides that you specify. So that's interesting. We got to figure that piece out. Okay, one or more launch templates and the instance types overrides that are used to launch EC2 instances to fill the on-demand and spot capacities. And this is required. So can we use... Okay, so then that means inside our mix instance policy, we need this, launch template. And then it's simply a launch template. Oh, okay, see what it's doing here? I think we can point this to the same launch template and then put overrides. So I think what they're saying is you can create multiple launch templates and then refer to those additional launch templates, but you could also override what's in your launch template. I think what we're going to do is we're going to do it like this. Okay, and then we'll go, what is our launch template? So yeah, this is the same as right here. We're just going to use the same launch template. Okay, so that should work there. And then we have the overrides section. And this is a list of launch template overrides. So let's see what we have to do here. Okay, so this is what we're looking at now. Instant requirements, instance type, launch template specification, and weighted capacity. Okay. So instance requirements. The instant requirements, EC2 autoscaling uses your specified requirements to identify instance types. Then it uses your on-demand and spot allocation to launch instances from those types. You can specify up to four separate sets of instance requirements per autoscaling group. This is useful for provisioning instances from different AMIs in the same autoscaling group. To do this, create the AMI and create a new launch template for each AMI. Then create a compatible set of instance requirements for each launch template. Wow. Okay. Now that's not required. So, and it says here, if you specify instant requirements, you can't specify instance type. So instead, maybe what we'll do is we're going to create a list of the various instance types that we want to use. Right? And yeah, it's a string value. You can specify 40 instance types per autoscaling group, and it's a string. Okay. So is that simply like this? What did we use the first time around? This thing's taken a long time to scale in, right? We're down to what, 13 instances? T4Gs. Let's have a look here. Oh, see, so yeah, it's scaling in slowly. It's going down. Okay, so we have T4Gs right now. Where did that where did that template thing go? Okay. So we're gonna say T4G nano. If it's a string, is it just like this? T4G small, T4G medium, and then we'll do this, M6G medium, just to throw in a different instance type, right? We use burstables, and then we just have one general purpose instance type. That doesn't look right to me, but it says a string, so let's see what happens. Launch template provides the launch template for the specified instance type of instant requirements, which we don't need to do because we didn't put instance requirements in. And then weighted capacity. If you provide a list of instance types to use, you can specify the number of capacity units provided by each instance types in terms of virtual CPUs, memory storage throughput, or other relative performance characteristics. When a spot or on-demand instance is launched, the capacity units count toward the desired capacity. EC2 autoscaling launches instances until the desired capacity is fulfilled, even if it results in an overage. For example, if there are 2 units remaining to fill capacity and the autoscaling group can only launch an instance with a weighted capacity of 5 units, the instance is launched. Okay. And the desired capacity exceeded by 3 units. For more information, see configure instance weighting for autoscaling. If you specify a value for weighted capacity for instance type, you must specify a value for weighted capacity for all of them. And again, it's a string. Can you give us an example of this somewhere? Is this required? It's not. I think what we'll do is we kind of met our goal for today. Now we're just kind of fiddling around with autoscaling. So why don't we see if what we've added here actually even works? Okay? Meaning, if we save this and we try to deploy it, I'll have to fiddle around maybe a little bit more with some of these other options and see if we can straighten it out. But let's see, we've added a fair amount here, right? We've added all of this mixed instance capacity or mixed instance policy. I'd be interested to see if it even works. Like if we don't have syntax errors or something like that. So let's do this. Added mixed instance policy. And we'll push that and let's see what it does. We're getting way down into the weeds now, which is kind of not what I wanted to do for tonight. I wanted to see if we could get that injector simulator to work, which we kind of did, so that's good. Well, at least the validation piece worked. Alright, there's EC2, so let's go back over here. We'll go to CloudFormation, find EC2. There's our change set. Alright, and conditional. So this is the big change that we made. I don't even remember what we did here that would have caused a change for that. Yeah, I'm not quite sure about that one. Okay, let's deploy it. I'll be shocked if this works. We made a lot of changes. There we go. Okay, valid requests must contain either launch template, launch configuration name, or mixed instance policy parameter. It's probably a spacing issue or something like that. Let me just go back and have a look at that. So what we did was we added mixed instances policies, right? Mixed instances policy. Okay. And that has instance distribution and launch template. So those are lined up okay. And then in launch template, we have launch template specification and overrides. So those are lined up properly. And then launch template specification can include launch template ID, launch template name, and the version. So we've got ID and version. Okay, that looks okay to me. And then we've got overrides, which is instance type. Did we miss something down here? Is the error message? Valid requests must contain either launch template, launch configuration name, or mixed instances policy parameter. And then we've got instance distribution, which is just a list of things. I don't know what we've done wrong here. This one's going to take a little more work. I think we've accomplished our main goal for today. We deployed the FIS experiment, the template, and then we ran an experiment, and we saw our auto-scaling group scale out, meaning adding capacity to handle the increased CPU load, right? And now, after that test is over, we're seeing it scale back in. Okay? So it definitely did what we wanted to. Maybe what we can do is work on auto-scaling in a future stream. I think what we'll do is we'll keep a shorter stream tonight. We did a marathon last week, and I got a few things to get finished up. So let's call it here because we got the FIS running. And we'll be back next week, and maybe we can work on just auto-scaling in general next week to see if we can figure this out. So until then, thanks for hanging out with me for a couple hours. I appreciate it as always, and we'll see you next week as we continue to build out some more CloudFormation templates. Take care.